Question 10 from the 2022 National 5 Physics exam from the SQA Section 1. The weights of three masses on the surface of a planet are shown in the table. Mass in one column and weight measured in newtons in the other column. The weight of a 6 kilogram mass on the surface of the planet is, and we're given 5 choices. Now the first step is to work out the gravitational field strength of the planet. And so we're given 3 bits of data there. It's preferable that we carry out those 3 bits of data to see if there's any discrepancies or changes. So we know right away that the equation leading up to the weight of an object is that its weight is equal to its mass times the gravitational field strength of that particular planet. So we can rearrange that to have the weight divided by the mass is going to equal to the gravitational field strength. So we take our first entry in the table. The weight will be 4.4 newtons, and we'll divide that by 0.5 kilograms, and we end up with an answer of 8.8 newtons per kilogram, and we'll write it like that. So that's just got the gravitational field strength based on that first result. Let's take the second lot of data. So we've got the weight to be 22 newtons, and we have got the mass to be 2.5 kilograms. So if we divide one by the other, we end up with the same answer again, 8.8 newtons per kilogram. Let's try the third one just to be safe. We've got a weight of 35 newtons. We divide it by the mass, which is 4.0, and that should give us the gravitational field strength, but in fact it gives an answer of 8.75 newtons per kilogram. But to 2 significant figures, we can confidently say that the gravitational field strength G for that planet is going to equal to 8.8 newtons per kilogram. So we're quite happy with that. So now we've got G, we can find the weight of any object on that planet. So the mass of 6 kilograms will give us a weight as follows. Weight equals mg, which is going to equal to the mass, 6 kilograms. I'm going to multiply it by the gravitational field strength we've just found out. It's going to be 8.8 newtons per kilogram. So the answer to that is going to be equal to 52.88 newtons. So working to 2 significant figures, that would give us a weight equal to about 53 newtons. So our answer to this question has got to be D. Question 11. A hairdryer is connected to a 230 volt supply. The current in the hairdryer is 2 amps. The electrical charge that passes through the hairdryer in 5 minutes is given by the following responses. We're looking up our relationship sheet. We know that the charge Q is going to equal to the amount of current flowing in a given time t. So Q equals I times t. The 230 volt supply is just here to be ignored. So therefore the current flowing is going to be 2 amps, but we have to change the time into seconds, and that means the 5 minutes will have to be changed into seconds by multiplying by 60. So we have 2 5s are 10, 10 times 60 is going to give us 600, and the units for coulombs is capital C. So our answer for question 11 is going to be 600, is going to be C. Question 12. The graph shows how the voltages across the components P, Q and R vary with the current. We can see the graph there of voltage and current. Now based on this graph, a group of students make the following statements. Statement 1. Component P has a greater resistance than component R. Statement 2. Component R has a greater resistance than component Q. And statement 3. Component Q has a greater resistance, has a resistance that decreases, as the current increases. Now we know Ohm's law, and Ohm's law states the following, that resistance R is equal to V divided by the current, voltage divided by current. Another way of thinking about that is that the resistance is actually going to be proportional to the resistance is actually going to be the gradient of that graph. So the resistance is going to be equal to the gradient. So if we take our ruler and measure the gradient of that graph, measure the slope of it, we can tell whether the resistance is big or the resistance is small. Let's take a look at the first statement. Component P has a greater resistance than component R. So if we go over here and we put in the graph and slide up to P here like that, you can see P has got a much steeper slope than R. So therefore P is the bigger resistance, because P has got a bigger slope than R. So our first statement there is going to be correct. Component P is a greater resistance than R. The second statement, component R has a greater resistance than Q, is done by the same method. We take our ruler and we move it across to the graph of R. That's it, lying on the graph of R, and that slope there is going to give us the value of the gradient. But if we compare it to Q, you can see it's going to have a much smaller gradient than Q, anywhere on Q. In fact, you can see Q up here, R down here. R has got the less value for the gradient, therefore it's got the less resistance. So component R has not got the greater resistance than Q, so we can mark that statement wrong. Now what about the third one? Component Q has a resistance that decreases as the current increases. Now the component Q is not showing Ohm's law because it's not a straight line, but we can take the gradient at little points on that curve and measure the slope and see if the slope is increasing or decreasing. So all we have to do is take our ruler and go to here, and I'm going to put the ruler on this part here and draw in a kind of line which is going to scuff that graph like that. So we'll draw that line in red here. So there's the first kind of gradient, or purple. There's the first gradient there. Now all we have to do now is take the next line, so we move up to the next point like that, and we can measure its gradient, and you can see scuff the line at that point, and we get this graph here. We can get this gradient, and you can see that the slope is getting smaller. And finally go to the third point in that graph and arrange your ruler to make the ruler scuff the graph. Just run along the graph, and if we take our pencil and draw the line like that, you can see very clearly there that the gradient is actually getting more shallower. In other words, the gradient is decreasing as the current increases, or to put it another way, the resistance is decreasing as the current increases, because the gradient is getting smaller. The slope is getting smaller as we go up the graph, as we go up the current. So statement 3 will be correct. Component Q has a resistance that decreases as the current increases. It's a component which is not showing Ohm's law, but we know that its resistance is going to decrease as the current increases. So we can see that we've got statement 1 and statement 3 are true, so the answer is going to be D.